Alexa Tinsley. I'm the Director of Programs here at Jett Foundation. I want to thank you all for joining us today for our community webinar series on turning ideas into reality, practical applications of 3D printing. I am very excited to share this with you and to have Bruce and Matt share their experiences and how it is beneficial to the community today. It's a really cool topic that I didn't know a lot about, so I'm really excited for you guys to learn more about as well. So with that said, I am so grateful to Matt and Bruce for helping us make this webinar possible and sharing their expertise with us. Matt is a 34-year-old living with Duchenne, and Bruce's dad to Gavin, who is also living with Duchenne. So they'll share all of their practical applications with you today and share more about how they got into 3D printing as well. Before we get started, I do just want to mention a few things. If this is your first webinar, it is being recorded. So if for any reason you can't stay the whole time, or if you know somebody that wanted to be a part of this webinar today but was not able, it will be recorded. It will live on Facebook, and it will also be posted on our YouTube later as well for you to share and watch later at your leisure. We will be answering questions after Matt and Bruce speak and present. So if you do have a question, there is a little box with a question mark at the bottom of your screen. That is where we will primarily be looking at questions, but we do try to monitor the chat to see if any come through there, and we do also try to monitor Facebook to see and take questions from there as well. But if for some reason we are not able to get out to all of your questions, or as I always say, if you need time to process and ask later, please feel free to reach out to us and we will get Matt and Bruce those questions and see if we can get them answered for you. So there is also closed captioning available to you today as well. There is a CC box at the bottom of your screen as well. You can click that and you should be able to translate it into any language that you need to translate it into. If for some reason you are having any issues with that, please go ahead and feel free to chat the hosts and panelists, and we will try to troubleshoot as well as we can. So with that, I'm going to go ahead and we are going to go ahead and get started. So there we go. All right. Matt, do you want to take this one?
Sure. Hello, everybody. Thanks for showing up. This should be a great event for everybody. I'm glad to share with all of you. So here we go. Basically, we'll start with just the basics. What is 3D printing? If you see here, basically it's called additive manufacturing. So basically you create a design digitally, and this converts it into a 3D physical object. Bruce, could you like to finish this slide?
Sure. So, okay, so 3D printing and uses filament, and I'm not sure if I'm zoomed in or not. I'm holding a roll of filament here, and the filament looks a lot like weed eater string that we're familiar with, and comes in either 0.5 kilogram or 1 kilogram spools, so about 2.2 pound spools, and you design a either you download or you design your own model, and you use software. It's called a slicing software, and the slicing software converts that to instructions for the printer to act upon. And the printer works a lot like a cake decorating tube, that it's just squirting out filament onto a build plate, starting at the bottom and building an object up. And it can be a slow process, but it's actually really powerful. I find it great that something I might be able to make in a few hours during the day with my hands, I can leave running overnight and the next morning have something for my son. But it actually removes a lot of physical labor, which I think is really great for for those of us with Duchenne, that there's something you can imagine, there's something you can draw it, you can click print and actually have it created. So let's look at Matt. Matt is really the driving force behind this presentation, and his notes here: it makes physical objects from 3D digital models. You can make plastic objects for your home. There are also metal 3D printers. And I've only ventured into plastic, but on the very high end of 3D printing. There are printers that cost tens, if not hundreds of thousands of dollars that actually print using metal. These actually typically work a lot like welding, but they're adding a little bit of metal on top. It's the same concept, just a much stronger structure. How it works, we create a design or we download a design. We export that from the software we created it in. You use a slicer program. You send the file to your printer, and then the printer takes some amount of time to create the object. Should we move on to the next slide? How it can benefit the community. The ability to create, adapt, and modify disability aids. I'm going to talk about this more later, but this right here is a beverage entry tool. And fortunately, I have a can right here. When my son Gavin was in probably 3rd grade, he found it difficult to open canned drinks. Well, this can go under the tab of a canned drink and pop it up, opening the canned drink, making it easier to open. From one side, we do this and then open it this way, and it acts as a lever to increase the force. And that's something that I think these cost less than 10 cents each to manufacture on a 3D printer. We gave away a bunch of them through Jett one year. It can assist with changing needs quickly. Great example, and talk about it later. My son's wheel bearings failed on his wheelchair. Wednesday evening, I replaced the front wheels, and I 3D printed some spacers that I needed to fit the new wheels. Being able to 3D print those saved me from having to go to the store and buy parts that might not have been available. Be able to create things that may not already exist or are too expensive. My son has 3 cup holders on his chair. All of them are 3D printed. Didn't have to spend more than a few dollars on filament and some time in them. Allows individuals to help themselves today. And it comes back to, this is a way that you can create a tool or a product or whatever it may be without having to do physical labor. Provide an avenue for higher learning, career paths, and business opportunities. Matt here creates products that he sells. I'm actually really proud of him. He's creating and selling products on his own that supplement his income. Okay, we can move to the next slide. Okay, Matt, do you want to read this one, or should I take it?
If you could read it.
Sure. Yeah, Matt is 34 years old with Duchenne. Matt says, I got into this after a period of major life changes due to progression of loss of strength. I had lost the ability to play video games at the level that I was accustomed to for the previous nearly 20 years. It just became frustrating, and that was where I left it. Around 2 years later, during lockdown, I was so bored, I just couldn't stand it, so I decided to look into this 3D printing technology I'd heard about. Truthfully speaking, it was the best decision that I ever made. I finally had a mission, something that I could really sink my teeth into. I could finally explore that side of me that always loved building things. I started creating things pretty quickly to help around the house. There will be videos of some of the items that I've created. And I have to say, I'm really impressed with everything that Matt has created. I think he's doing really well, and I hope to see others do the same. Okay, so my story. So Gavin was diagnosed after 8 with Duchenne, and Gavin, is really integrated in everything we do, and something we do a lot of is boating at time on the lake. And I wanted Gavin to have an option that did not require him to swim all day long on the lake, to give him something else to get out of the water so I could swim for a few hours and then have some way of relaxing. I decided to build a bumper boat. I wanted it to take a swim tube, like a river raft, and convert it into a seat that he could ride around in. He could drive himself around in, and that he could have some fun with. So I added a water gun to it. And I had built the electronics to drive it through the water. But the biggest problem that I had was trying to build a waterproof housing to contain the joystick. And every time we would test this, within a few hours, the joystick would be waterlogged and it would fail. I bought a 3D printer out of frustration of not being able to get this to work. And after a few months of trying, I actually was able to produce a waterproof joystick. Could you play the video, please? So this is Gavin in the tube, and it uses two jet thrusters that might be used for a radio-controlled boat. And the blue controller in his hands is, my first real success in 3D printing. It actually uses a rubber boot over the joystick, and that rubber boot itself is 3D printed, as is the controller housing. And between his legs is a sprinkler head that operates as a water gun. And you can see he's my wife was videoing. She's protecting her phone as he's spraying her water. But this was a really fun toy for him that we used for a couple of years. We now have replaced it with a single thruster that goes on a pool noodle that allows him to stay in the water and just drive around. Okay. Would we like to move to the next slide? Okay, so we're getting into some of Matt's creations here. And Matt, if you want to take over, just let me know at any time. If not, I'm happy to continue.
Sounds great.
So this is something that Matt designed and created for himself, and it's a remote control mount for his bed. And he's 3D printed a plastic holder for the remote control that he designed himself. And he has included a magnet on the back so it can stick to the bed rail. So he can have this remote control anywhere he wants to. He doesn't have to fumble to try to find it in the bed. It's just stuck there where he needs it. I think this is a really cool adaptation that I expect makes his life a lot easier.
Matt, do you want to elaborate at all or move on?
Yes, it definitely makes things easier. My caregivers will constantly try to find it. I broke two remotes, so I decided I needed to create something to prevent that. It works well. All right. So this is a dog treat dispenser that I created that connects to my chair. That's something I use every day. And it's something I think other people could really use.
Well, Matt, it's very cool. You actually speak to it to tell it to release a treat. Is that
Yes.
correct?
Yes.
Yeah.
That's right.
That's very cool. And you had to size things correctly to fit your dog treat. And I'm assuming are you using a solenoid or a motor in there for the release?
So it's actually a gadget. It's called a switch bot.
Okay.
Some of you may be familiar. Basically, it's a smart button pusher. So I use those for most of these designs just to automate things.
Very cool.
Yeah. Okay. And here's something similar, except this shoots the treats very far. My dog quite enjoys that.
That's very cool.
All right. This is actually the first thing that I created. Basically, the issue was getting all the way to the desk. There's just a pain. So I came up with this design, basically so I could sit back in a comfortable spot then still use the mouse.
Yes. So it slides in and out and swivels.
That's right, yeah.
Yes.
So it's out of the way if you need it to be.
Yeah, that's very cool.
Okay. And this is actually the reason I initially started printing. This is a custom controller mount for my chair. Basically, I lost the ability to drive with the basic joystick, so I had to get the micro joystick. But the setup that the provider brought to me just was not going to work. So this is what I came up with. This is about 3 years old at this point. Still very strong. And it's something I use every day, clearly. All right. And this is something I came up with that basically just prevents me from getting scorched, get a shower. One of my favorite creations. Pretty simple, but it's a major help.
Make sure no one sets your shower too hot. That's cool.
That's right. Okay, this again, it's a switch bot, but that is a life alert remote control. Basically, of course, I can't physically push it, so I made this basically a mount for it, so that using the switch bot, I can activate the life alert just by voice.
Matt, what do you use to operate it like through your
So,
voice?
so you can use either your phone or Alexa or any smart home device.
Awesome, thank you.
Yeah. And here I wanted to be able to control if it to go outside, get inside, for the pocket. Again, it's all voice control. And this is his cage, which I needed to figure out a way to open it. But I need to. And again, this is 2 years old, still works great. And it's very useful.
Very cool. I really like the dog door.
Yeah, it turned out great. And this is just a basic cover to go over the on and off switch on the left. It was always getting pressed because people would love it. So just a quality of life feature.
That's cool. I like how you've created things that improve your life.
Yes, it's been great. Yeah, this is just a full shelf that I created for my blood pressure cuff that sits inside the closet. It's out of sight, but it's there if you need it.
Very cool.
Pretty is excellent for storage, organization. It's great for all that as well.
Okay. So we've moved on to my slide. So here are three designs that I've created. The first one, and I really didn't build this one for Gavin, but in the first picture to the left of the swim tube, the bumper boat swim tube design was a picture of Gavin in the lake with me. And the two T's on the left work with a pool noodle or two pool noodles, one to go around the waist and then one that loops as a U underneath through the legs. And the purpose for this design was just to create a noodle setup that someone could not fall out of. And it doesn't require core strength to stay upright because it actually holds you within the noodles. And I've given a few of these to friends. I've sent the designs to others. In fact, the design for that is published online. So if anyone wants to, you can download that design. I have that link from the Bruce on DMD Facebook page, and you can grab the design and have a local maker space printing, or if you have your own 3D printer, print them yourselves, buy a couple of pool noodles, and have what seems to be a very safe way to spend time in the water. The second one there, I actually did a preview of the beverage entry tool. These, went to school in Gavin's lunch for several years. He actually uses cups now instead of cans, so we're not using them anymore, but they make it a lot easier to open canned drinks, which works really, really well for him. The third one is something that Doug Levine of Cure Duchenne and I came up with, and Doug had wanted a low force arm exerciser. There's no resistance. It latches over a door opening and uses a pulley at the top with it's actually paracord, but just string between two D handles. And when you raise one arm, it lowers the other and vice versa. And it provides just a very, very low force arm exercise. Gavin did use this for a while. I'm not sure how widely it's been used, but it's something that can be printed with a few dollars of plastic and a little bit of string, and seems like it does have some exercise benefit. Okay, now looking at Gavin's wheelchair, this probably is where that I've used the 3D printing for him the most. On the left, Gavin's legs were spreading out, which is pretty common with Duchenne. And we wanted to align them straight. And we noticed in his chair at home, he sits in an Arion office chair at home. And the Arion chair, actually, it's ergonomic and it's actually somewhat curved at the bottom. And it actually keeps his legs pointed out straight. So we decided we wanted to replicate that with his wheelchair. This was the first version of the design, which actually clamped to the round tube sides of his chair. Later, I made a version that's just L-shaped pieces that Velcro to the bottom of the seat cushion, which is what he currently uses now. And those are available for Thingiverse, and they're linked from the Bruce on DMD Facebook page. And you can download them and print them with a couple of dollars worth of plastic and get some Velcro or double-sided sticky tape and stick them to the bottom of the seat cushion and install them in a few minutes. And they do a great job of keeping his legs sticking straight out instead of at angles. And that makes him much more comfortable in his chair. The second one here is a breakfast tray. And Gavin's chair is he's using a folding portable chair, which he really likes. We've talked to him about getting more complex, more expensive chairs. He just doesn't want to change at this point. And there are some benefits to the lighter weight chair, and he likes that we put the best cushions we could get on it. But sometimes I feel a little bad about the kind of inexpensive chair he's in, but he loves it. It happens to have round tubes under the armrests that are great for mounting things too. And this breakfast tray, we needed something for him to help him to eat breakfast on the way to school. And it incorporates a cup holder. You can see it's the round area in the middle, and then several areas for different types of food or utensils, sort of like a lunch tray at school. And it has a round section that plugs into the chair arm, making it very fast to install. We used these for a couple of years until he needed a larger desktop surface attached to his chair that we're using now. But these worked really well. If I remember correctly, it's about $7 worth of plastic to print one of these, and it was sort of an overnight. It might have been a 24-hour print. It was a longer print, but it was something that we probably broke 3 of them over a couple of years. So they served us well at a very low cost. Then on the right side, we have a headrest mount. Gavin's chair did not come with a headrest. And before he had spinal fusion, it was suggested that he needed a headrest. So the large blue block across the top rail of his chair is a two-piece plastic clamp that was 3D printed. And I bought a $30 or $40 headrest off the internet and just mounted it to that to give him a headrest that would serve well on his chair. And you can recline the headrest forward, or you can move it forward or backward. Spinning it on that block will allow it to rotate a little bit. It has nuts on the back that I didn't show, but they are 3D printed nuts to allow you to tighten or loosen it to allow movement in there. You also, in this picture, you can see, if you look down at the bottom left of the chair, you can see some of the cup holders that are mounted to the side of this chair. Okay, let's move to the next slide. So on the left here, this is the new leg aligners. You can see on his thigh there, holding his leg in place, facing straight out. His table that is there is mounted using 3D printed parts. This here is one of the spare mounts for his table holder, for his table. And the wood of the table slides into this gap here in the plastic. And so the table actually comes on and off with just one single bolt. In the middle, we have an image that shows two cup holders, one at the front, one at the back. You can see I have several empty cups stacked into one of the cup holders. And it holds 3 pens, and there's actually a couple of little trays there that he keeps cough drops or candy or hand sanitizer in. On the right, this one is just all fun. Gavin had, I believe it's Link's sword, and was headed to an event where he wanted to have the sword, and I 3D printed a holder for the sword that sockets into the same round tube that the breakfast tray did, and it allowed him to have his sword sitting there at the front of his chair for the entirety of the event, which was really nice for him. Okay, this actually was a recent upgrade that we had a trip to New York City, and I wanted to extend the range of his wheelchair. And his wheelchair had a 3-year-old lithium-ion battery in it, and the battery was tired. I opened up the battery housing, the black plastic box on the left, and found that what was inside was just a small battery pack that did not nearly fill the battery housing. And ordered battery cells to build a replacement. It actually was very convenient timing, because after the day with the cells came in, Gavin had a battery failure, had some weakness of his battery at school, so I ended up rushing this to completion. But I 3D printed in the middle. You can see half of a housing to hold batteries, and I printed 4 of these and used them to assemble the batteries and hold them together securely. Lithium-ion batteries are something you want to be very careful with. You want to use good quality batteries. I purchased Samsung batteries. You don't want to solder on them. I spot welded the nickel strips that connect them together. And you don't want them to rub against each other and have abrasion. By using the 3D printed holders, we also don't want them to overheat. I was able to, by using the 3D printed holders, actually able to enforce spacing between the batteries, so there's an air gap between all of them. On the next slide, we'll see more of this battery pack. Alexis, could you go ahead and...
Yeah, Bruce, actually, for some reason, they didn't come through. So I rearranged, so I'm not sure if you have them to show, but
there we go. That's
it.
They
do show. Great.
Okay, so this is on the left, we have 1/2 of the battery pack. I actually built 2 of these, and Gavin used one at school for over a week, because I was in a rush to build one to get him back on the road, and he went to school with just one of these for a while before our trip to New York. The second one was added, and on the right side you can see the battery all sealed up in the original housing. It looks just like the original battery. I scaled everything to fit in the original housing. We went from a 12 amp hour battery to a 20 amp hour battery. And in our biggest day of walking in New York, he rolled more than 9 miles, and the battery was still strong at the end of that. So I think it worked pretty well. Okay. All right. So this project actually happened on Wednesday evening. While we were in New York, one of his front wheel bearings failed, and his wheel started to make a squealing noise, and then later a loud thumping noise as the wheel bearing failed. I tried to source new wheels and have them delivered to a hotel room, but just could not get them in time. So I guessed about the size of the wheels and had them delivered to our house. We arrived home on Wednesday about 6 p.m. He was headed to school about 7 a.m. on Thursday. So I forcefully removed the old wheels. They were pretty stuck in place. Once I got them off, I found that the hubs of the original wheels stuck out about 5 millimeters on each side, and that the new wheels did not. So I needed spacers to hold them in place. I was able to draw the spacers in a matter of 5 to 10 minutes, and it took about 30 minutes to print 4 of them. I actually printed them while I was having dinner with my parents, and then put his chair back together with spacers, and he was at school on Thursday and today using those spacers. And these are something that should hold up for years. I printed them out of a type of plastic called PETG that's a little flexible. It holds up to heat well. They should last for a very long time. Having a 3D printer and being able to print these saved me having to go shopping in the evening and look for what I might be able to find to make them out of metal or otherwise purchase spacers. It just was a major time saver to be able to do it this way. Okay, next one here is a Quiz Bowl controller. And I don't know how many of you are familiar with Quiz Bowl, but it's a Jeopardy-like competition that is held among school students. And the traditional controller is either a box that sits on a desk or a controller you hold in your hand. Those red buttons that you see there require quite a bit of force to press. And Gavin was asked to participate in Quiz Bowl at his school. He actually has a lot of knowledge and is doing really well with it, but he just couldn't press the button. And that was going to be a major problem. So I think about 1.5 years ago, Gavin and I sat down and we brainstormed. We tried different methods. And what I came up with was to place a button on a long lever attached to a switch so that we could significantly reduce the force. And that worked out with creating what's on the right-hand side, which uses 2 3D printed parts. Actually 3, being the button, the bottom, and the top. And we use this lever that you're seeing there with the switch, and it creates a controller that requires just very, very minimal force to press. And Gavin has been winning Quiz Bowl competitions with this. So, Matt, do you want to talk about the software, or should I?
Sure. Okay, so there's a wide variety of software that we use to create these things. Generally, it just depends with what you start with. Basically, do you go as simple or as extreme? Because you like with these programs, you don't need that much knowledge to make things. Very simple things. Wheel spacers, like Bruce was showing us. Very simple, but very useful. Yeah, Bruce, could you break
Sure,
that
I'd be happy to.
software?
Yeah, so Tinkercad is a very simple, very basic tool that allows you to draw shapes, to work with shapes. And it's something that a lot of schools are utilizing and teaching. I know that both of my kids have used Tinkercad at school to design things, and they'll do things like Christmas ornaments or toys or things that they want to draw with them. And if the school has 3D printing, will actually go ahead and 3D print them. It is where most people start. It's really easy, and I think it's probably the best place to start. I think, Matt, do you use Fusion 360?
Yes, I do.
So Matt and I both use Fusion 360. Autodesk is the company that is behind AutoCAD. That's one of the longest standing, most successful CAD programs. Fusion 360 is sort of a light version that's more focused on the 3D printing world or designing smaller items, where AutoCAD, you might design a factory or a home. Fusion is better suited for smaller items. I'm assuming Matt's using a free version. I actually am paying for the startup version, which is a heavily discounted version of it that I've been using for several years. But it's a 3D CAD program through which you can draw designs. You can download your designs to save them forever. When you 3D print something, you typically want a type of file. It's called an STL, and it allows you to export STL files of your designs. It is a web-based platform, so you have to continue to subscribe or have free access to be able to continue to use it, which is one thing that does concern me about it. Onshape and SolidWorks are competitors to Fusion 360. SolidWorks, I think, may actually have been around a little bit longer. Onshape is free. SolidWorks, there is a EAA, which is a Model Airplane Club membership through which you can get it for $24 a year. And how do you learn to use these tools? And in fact, before we do that, I'm going to just throw in here, there are several websites that have STL files that are created by others that you can download and use. So when I started printing, the first thing that I did, I bought the printer and I bought filament, and then I started downloading other people's designs because I wanted to understand what the printer could do and how it worked. So I printed toy cars, and this is this boat here is a very common 3D printer calibration model. But I printed calibration tools. I printed toys. I printed anything that I thought was interesting, just so I could learn what the printer could do. Because when you're designing something, it works out a lot better if you understand how the printer might print what you're going to draw. So I highly recommend for anyone who does acquire a 3D printer, try the toys, try the fun stuff, and just enjoy using it. And I wouldn't focus at first on creating your own designs. I would use other people's designs to become familiar with it. But learning to draw in CAD, schools have a lot of schools have classes, and my kids have done this in middle school, in junior high, and in high school, where they are designing programs using CAD. Maker spaces, I know the community college closest to me has probably a dozen 3D printers in their maker spaces. So there's an opportunity to interact with professor level people and the people that work in the maker spaces to learn more. And then there are a lot of YouTube videos, and I find myself looking at YouTube videos trying to understand how to design things that are beyond my thinking. For me, it was a challenge to go from thinking about drawing something in 2D to drawing something in 3D. And it takes some adaptation. Matt has done incredibly well with that. I'm impressed with his designs.
Oh, thank you. I just used YouTube tutorials. There are thousands.
Yes.
Very smart people that teach you every single step of the way.
That's great. Okay, so financially, there's a cost of the printer, but then the cost of actual printing. Early on, I was concerned about the cost of how much filament would cost. I looked at a $500 printer and thought, well, how much will I spend on filament? Um, the I tend to buy in bulk, and I pay about $12 a kilogram if I buy 10 kilograms at a time of filament. If you're buying one roll at a time on Amazon, you're probably paying more in the $20 to $25 range by the time you add some tax to it. But a kilogram of filament can go a long, long way. It depends on what you're printing. Something like Gavin's breakfast tables were somewhere between a third and half a roll of filament. Something like these, the beverage entry tools here, they are, 10 cents a filament. It's all about just what you're printing, and even larger things may not require a lot of filament, because when you 3D print something, you have it's not typically it's not solid. You actually have air in the middle and some sort of grid structure. I tend to use honeycomb infill in the print, so that you have it's not everything is not completely filled. It has gaps in the middle that reduce the amount of filament. Repairs, maintenance, and consumables. This is a big factor. I have Creality printers, and Creality printers they're cost conscious printers. And for example, Creality has $150 Ender 3 printers that you receive in a box and you assemble and calibrate before you can print. And my experience with Creality is that when I was using mostly Creality parts, I was having to disassemble and clean and recalibrate my printer about once a month. I was printing quite a bit, but it was sort of a monthly task for me. Over time, I upgraded most of the components of the printer. My Creality printers now, only the metal parts really still are Creality, only the metal frames. And now it's probably every 6 months that I end up doing sort of a tear down and rebuild and recalibrate. Matt, I know, recommends the Bamboo Lab printers, and Bamboo Labs has come out with some of the easiest to use, fastest printers on the market. They also have the ability to add on 4-color automated filament switching systems, so you can print in 4 colors, which is a really cool feature to have. I probably am going to add a Bamboo Labs printer in the future. I just saw that Jonas says he has a Prusa Mark III-S, which is a higher quality printer than the Crealities that I have.
Yeah, that's right.
Yeah.
That's right. For the Prusa.
Yeah, you had the Prusa?
That's what I started with.
Okay. Yeah, and Prusa makes really excellent printers. The amount of maintenance and costs if you're buying Prusa or Bamboo, you're going to have less maintenance than the Creality printer. If you want to get in cheap, the Crealities are a good way to try it for less money. Now, saying that the 2 Creality printers that I have retail prices of $600 and I think $1,000 on the max. So I didn't buy cheap printers, but I did buy bigger, more capable printers from a cheap company. Occasionally, lubrication and cleaning. You create a lot of plastic mess, a lot of plastic dust. I find it really useful to vacuum the printer. And yes, the metal surfaces that have friction do need lubrication. You also want to be really careful not to get any type of oil on your print surfaces. And some parts may need to be replaced more often than others. The printing mechanism, the extruder pushes the filament through the printer. The filament is like a weed eater string. I find that the extruders are the parts that have the most wear. And the extruders and the nozzles that the print filament actually comes out of seem to have the most wear. Printer options. There are many manufacturers out there, but Bamboo Labs printers are recommended. They really stormed into the market and set the bar quite high. You could say their devices are equivalent to Apple devices because they generally just work. They have an app that works very well. You can discover other people's creation and start the print directly from your phone. They offer a variety of machines. They all work great. They have a pretty good price range. It makes it easy for people to get into 3D printing. Yeah, and Matt, that price range is, I think, about 250 up to about 2,000. Is that
Yeah,
your?
that's fair.
Yeah.
Yeah.
Yeah, I've not yet ventured into bamboo. I think I probably will, and maybe even this week. They have a sale going on right now, but they do have they do make really cool printers. And if I was a parent buying a printer for my son and I didn't want the hassle of tinkering with it, it is the way that I would go.
Exactly.
Awesome.
Much.
So go ahead, Matt.
Sorry, that was it.
So before we get to our Q&A, we have a very, very exciting announcement for all of you. So we are going to be doing a 3D printer giveaway this year. All families and individuals impacted by Duchenne that fit the below criteria are welcome to apply. So you do have to have a confirmed Duchenne diagnosis, a physician letter, not your genetic test. You have to have a PC or Mac, must live within the United States. The application is open now and will close on December 18th. And then awards will be announced the week of December 23rd. So we're really excited to be able to do this giveaway and hopefully, get it into one of your homes. It is something, like I said, it's something that I never really even realized how cool and cost effective and beneficial it was. So I hope that all of you have learned something today and want to maybe start getting into it. So I will go ahead and put in the chat the actual link so that you guys can see it. Feel free to pass it along as well. If you do have any questions when you are filling out the application, please reach out to info@jettfoundation.org and we'd be happy to answer any questions that you have. And also please feel free to put them into the Q&A now if you have them quickly, or but if you have any after the webinar, please feel free to reach out to us at info@jettfoundation.org. So with that, I'll go ahead and we will open it up for questions and answers, and we do already have some. First question, have you ever explored getting designs printed in metal with a third-party company as opposed to in-house with plastic filament? I've made attachments myself and printed them, but they often break.
Okay. So I don't,
Okay.
Matt, you want to take it?
Yeah, so basically these days, there are 3 or 4 giant companies that do this. They do excellent quality. And got to see some very cool things people have created. Because while the plastic is quite strong, sometimes you have good applications that you need steel, you need aluminum, titanium. So that I haven't tried it, but I do intend to.
Yeah, and I'm gonna add to that. Whoever has the question, if you want to reach out to me afterwards, I'd be happy to talk about trying to strengthen the design so maybe you can get plastic to work. Most 3D printing occurs with PLA, and PLA I like. It's corn oil based. It's very environmentally friendly. I actually almost exclusively print with PETG, which is very similar to the plastic milk bottles are made out of, and it's flexible. And PLA is brittle, so PLA tends to break if you bend it. PETG, I don't know if you guys can see that this is a PETG disc, and that is a lot of force going into it. This disc is about 3/16 of an inch thick, and there you go, it broke. But I don't know if you can see that there, but you may be able to see the air gaps. Not sure if that's going to focus or not. I don't think it is, but you can see it took a huge amount of force to break that. So if you use PETG as your printing, your material, you can make some very, very strong designs without them having to be very thick.
Awesome. Do you create prototypes or do you get these devices to work for you on first try?
There's always prototypes. In fact, that's the best thing about 3D printing. You can iterate very fast, try things out. If it doesn't work, you wasted 30 cents. That's great for rapid prototyping.
Yeah, I also, I every once in a while something works the first time, but it is really common to print something, it's not quite right, modify it and print again.
Awesome. I really like this question, so I'm interested to hear the answer, but are there any modified programs or equipment that would allow older adults with DMD to be able to 3D print things that they may need? For example, perhaps someone that uses technology such as eye gaze and may not have use of their fingers and arms.
So, for example, with bamboo printers, they have the mobile app to basically, I use that with just voice control. If there is something that's needed, uploaded there, you could do that fairly easily. But as for eye gaze, I'm not sure, but I'm sure there are ways.
Bruce, do you know of any?
So I would think that if you can control your computer with eye gaze or other tools, that you also would be able to create the designs to 3D print. The actual removal of the print and movement of the print is something that you would probably need assistance with. And this is something that I grabbed. I keep a bottle of just isopropyl alcohol, rubbing alcohol around, and find it makes it a lot easier to remove the prints from the surfaces. But once you print something, it can be very stuck to the print surface, and spraying alcohol on it actually helps to soften the removal process. But again, I think if you have the ability to control a computer or even an iPad or an iPhone, there are 3D design programs you could use with that control method, hopefully, and be able to design something. Then at that point, I think you're going to need some assistance from family or caretakers.
And I think we'll end on this question, and I absolutely love it. But what is the favorite thing that you have made? And I will leave it to Matt first to answer that question.
It's kind of a tricky question. Probably the thing I use the most, which is the wheelchair joystick mount.
Bruce?
That's a really hard one, because it comes down to what gets used the most. I've made some things that I felt were really cool, but the thing that really gets used the most is cup holders and pen holders on Gavin's wheelchair, and the table on his wheelchair. But just the wheelchair accessories that I've been able to make that he wouldn't have otherwise. And the table that is mounted to his chair. Did we drop out of the webinar?
No, you're still here. I just stopped
Yeah.
sharing my screen.
Oh, no, that's fine. Yeah. The table that's mounted to Gavin's chair was put together over a weekend. On a Friday, we went into his on a Friday we went to an open house at his junior high and found that instead of having tables that he could drive under, almost all the classrooms only had desks that he would need to transfer into. So I printed the mounts and cut the wooden table out of a piece of scrap plywood, expecting that I would upgrade it to something else in the near future. But a year and a half later, we're still using it. So the 3D printing has allowed me to really help him and provide the things that he needs, which I probably the greatest thing is actually that he enjoys using these things and I get to enjoy making them for him.
But the best part is that if you break it, just print a new one.
Yes.
That's That's great.
Well, awesome. Well, thank you everybody for joining us today. If you do have any questions for Bruce and Matt, are you guys okay if we share your information if people reach out?
Absolutely.
Perfect. So please reach out. We'll get you guys connected. Thank you again for being here. If you do have any questions about the giveaway, again, reach out to info@jettfoundation.org. Thank you for being a part of our webinar today and spending the 3:30 hour with us. We really appreciate all of you. Hope to see you again soon. And Bruce and Matt, thank you, because we absolutely could not have done it without you.
Thank you as well.
Bye, guys.
Bye.